Okay, so let's start. I hope I'm audible and you can see me. So, welcome. I am Shivani Dhok and welcome to the very first tutorial for the course of Principles of Signals and Systems. So, we'll have majorly a recap of whatever was covered in the week. That is, in this tutorial, we'll majorly focus on week 1. We'll revise the concepts that were taken in week 1 and solve some questions that will give you some more insights and will help you solving the assignments. So this session is majorly for you all. So if you have any doubt at any point for any concept, just stop me at that point. So after doing a recap, let's stop for some time, and if you have any doubt in that concept, we'll clear that and then we'll move on to solving the questions. So I hope it is fine with everyone, and I'll start sharing the screen. I hope the screen is visible to everyone. Just give me a confirmation in chat or unmute yourself and let me know. Can someone please give me a confirmation in chat that the screen is visible? Yeah, okay, thank you. Thank you. Thank you. Okay, so let's start. So in the first week, you all got an introduction for the basic two components of this course, that is the signal and system. So while defining the signal, it was defined in a way that it is a physical quantity that conveys some information about some phenomena that and it is varying with respect to time. So the very basic example of that is your voice signal. So your voice signal strength is going up and down with time. Like when I'm speaking, my voice is changing with time. So it is a time varying signal. Similarly, if you are seeing this video, you are seeing my screen. So here this video is changing with time, as well as at every pixel there is some different value of let's say intensity of color intensity or different values of RGB that are present at any particular location, say here. And again, when I'm changing my slides, it is getting changed. So this is a change, that is a signal that is varying with respect to space as well as time. But now we can't have only signals and say that okay, we are fine with signals, and we'll have to do some processing. Like when I'm speaking, I'm having this microphone attached with my earphones. So this microphone is basically some system that is actually capturing my voice signal, then converting it to electrical signal, and then transmitting it, like whatever further process is there. So whatever is there between my voice signal and whatever you are listening, there is some sort of process that is happening. That is, suppose this x of t is my voice signal and this y of t is whatever you are listening. So whatever process is happening between these two is basically characterized by a system, and we need to analyze how this system functions, so that while processing or while developing this system between my voice and whatever you are listening, we should have a proper interpretation, or we should have some proper output that we are desiring, and hence we need to characterize this system, and this system will help us to understand the interaction between this output and this input. So this was the definition of signal and system that was given to you. And then sir went on to give you give you different categories or classification of signals. So there are different classification of signals, and the first one was that was given was based on continuous time, discrete time. The next one was given as analog, digital. Then it was defined for odd and even signals. Then energy and power. Then it was based on periodicity, and then deterministic and random. So this symmetry of odd and even, then periodicity and energy and power signals, we are having some examples. So we'll go into its detail, like how it is characterized while solving those examples. But apart from that, if you have any questions for other categories like continuous time, discrete time, or any other things, just pause me and ask me right now if you have any questions about it. Please unmute and ask the questions. It would be easy for everyone also. Okay, fine. And after that, we went on to discuss one simple classification of system which was based on causality and memorylessness. So for that also we have one question. So we'll discuss that majorly while solving those questions. So if you have any doubt regarding these things, just let me know. Else we'll go on and start solving the questions. Okay. So let us look at this first question. So it says that classify the following signals as even or odd signal. So what do you mean by an even signal? So suppose if we have x of minus t is equal to x of t, then this kind of signal will be known as an even signal. So basically it is symmetric about your x of t axis. That is, if I am plotting it something like this will be my x of t and this is my t. So this even signal will show some symmetry about this x of t axis. Maybe it's something like this, or it is something like this, or it is something like this. So such kind of signals are known as even signals. And the other category is odd signal. For this, your x of minus t is equal to minus of x of t. So if you flip the signal about your vertical axis, as well as around your t axis, that is, it is something like this kind of signal. I'll give you an example of sinusoid. So sine is like this, and so on. So if you look at this part here, this peak to peak, let's say it's anyway periodic, so it will extend. So we see that there is no symmetry about this, like this x of minus t is not equal to x of t. But if you flip it, like if you consider x of minus t, it will be something like this. So it is not same. But if you go on and flip it about this t axis, so this is basically x of minus t, and if you do minus of x of minus t, then it will be something like this. So you can observe that this signal and this signal, they both are same, and whichever signals exhibit this kind of symmetry, those are known as odd signals. So this is odd symmetry, and whatever is exhibited by this is known as even symmetry. So if you have x of minus t equal to x of t, then they are even signals, and if you have x of minus t equal to minus of x of t, then they are known as odd signals. So the question is whether the following signals are even or odd. And the first signal that is given to you is x of t is equal to u of t plus 2 minus u of t minus 2. So what is this u of t? This u of t is your unit step signal. And how does it look? So basically it is defined as u of t is equal to 1 if t is greater than or equal to 0, and it is equal to 0 otherwise. So if you draw this signal, how will it look? So till 0 it is all 0, and from 0 it starts to go to infinity and takes the value as 1. So this is your u of t. But here what we are given is u of t plus 2. So how will this signal look? Basically, we are shifting this signal leftwards by 2 units. So how can you understand that? You can just look at this part here, t plus 2, and let's say we say this t plus 2 as t hat, and this is equal to t plus 2, which implies that t equal to t hat minus 2. So this u of t hat, you try to understand this. If my t hat is equal to 0, then what will be my t? T will be minus 2. So whatever was present at 0 will be then shifted to minus 2. So basically we are just shifting this signal, by 2 units leftwards. So the signal of u of t plus 2 will look something like this. So let's say this is minus 2. So the signal will look something like this. This is u of t plus 2. And the next signal that we have is u of t minus 2. Again, if we consider this t minus 2 as t hat, then we can see that whatever was present at t equal to 0 will be now shifted to t equal to 2. So this u of t minus 2 is basically a shifted version of your unit step by a factor of 2, but now rightwards. So till t equal to 2, this signal will be 0, and then it will be 1. So this value will be 1 here. But what is our x of t? Our x of t is u of t plus 2 minus of u of t minus 2. So it is difference of these two signals. So our x of t will be starting from minus 2 and going till 2, till minus 2 it will be 0. Then you can see here, if you subtract this part from this part till this 2, will get a value of 1. So till 2 we'll get a value 1, and after that we have one amplitude for both the signals which will cancel out. So again we will be having it as 0. So you can observe that this is my x of t. So what will be your x of minus t? So x of minus t for x of minus t, whatever was present at 2 will be available at minus 2. So whatever was present at 2 will be available at minus 2, and whatever was present at minus 2 will be there at 2. So this is my x of minus t. So we can observe that both of these signals are same. That is, they are equal, which implies that this x of t is an even signal. I hope this question is clear. If you have any doubt, please ask. Okay. Now let us look at the second question, that is x of t is equal to t into u of t plus 2 minus u of t minus 2. So this is the signal x of t is equal to t multiplied by u of t plus 2 minus u of t minus 2. We have seen this signal in the previous question and it appeared something like this. That is, it was 1 from minus 2 to 2. And it was 0 for all the other values of t. And there is another component that is here, that is t. So how does this t look? So it will be a straight line with slope 1 like this. And our x of t is multiplication of these two signals. So the x of t will be this signal. So we can observe that till this part x of t will be non-zero, but outside, that is whatever, whenever t is greater than 2 and whenever t is less than minus 2, it will take a 0 value, else it will be equal to t. So we would be getting something like this. And this is our x of t. Now let us try to draw x of minus t. Let us try to draw x of minus t. So x of minus t is obtained by taking a mirror image about this x of t axis, that is this vertical dependent axis. So that will give us a signal which is something like this, and this will be again non-zero from minus 2 to 2, but now at minus 2 we will be having value of 2 and at 2 we will be having a value of minus 2. Now it is clearly, we can clearly see that these two signals are not same. That is, these are not same. But now suppose we flip it about this t axis, then we get something like this. That is, if we take minus of x of minus t, we get something like this. Again, here we have a value of 2 and here we have the value of minus 2. And if we look at these two signals, these are equal. That is, what we are having is your x of t is equal to minus of x of minus t, or in other words we have x of minus t is equal to minus of x of t, and therefore this is an odd signal. Is this example clear? uh, does anyone have any doubt in this question? Please unmute yourself and ask the doubts, and you can just pause me anytime if you don't understand any particular step. So let us look at this third part of this question, and it says that your x of t is equal to ut minus u of t minus 2, where this u is your unit step signal. So we saw how this u of t looks. So it is 0 till 0, and then it becomes 1. So this is t, this is u of t. Then your u of t minus 2, we have seen that it starts from 2, that is it is 0 till 2, and then it takes the value of 1. So this is u of t minus 2. And what will be your x of t? Your x of t will be a pulse kind of thing that will be non-zero from 0 to 2, that is it will take the value 1 from 0 to 2. And then it will be 0. So this is your x of t. So let us see if this follows any kind of symmetry or not. So let us try to see what is x of minus t. So x of minus t will be something like this. That is, whatever is available at 2, it will be available now at minus 2. And till minus 2 it will be 0. That is, you are just flipping and finding a mirror image about this vertical axis. And it will be 1 till 0, and then again it will become 0. So this is your x of t. This is your x of, this is your x of minus t. And clearly we can say that x of t is not equal to x of minus t. So this is not equal to x of t. Now let us look at minus of x of t. So minus of x of minus t, that will be 0 till t equal to minus 2, and then it will take a value of minus 1. This is 1, this is minus 1, and this is your minus of x of minus t. So again this is not equal to your x of t. So this signal here, x of t, which is u of t minus 2, is neither odd nor even. So this is neither odd nor even. But any signal, any given signal can be decomposed into odd and even components. So what I am saying is any signal x of t, whether it is odd or whether it is even, can be decomposed into its odd component, that is x odd of t, and even component, that is x even of t. So this is odd component and this is even component, and this x odd of t, that is xo of t, is given as x of t minus x of minus t by 2. So how I am claiming this is an odd component. So look at this x odd of minus t. So this comes out as x of minus t minus of x of t by 2, which we can simply say that it is equal to minus of x odd of t. So this is equal to minus of x odd of t. Similarly, this even component, that is x e of t, is given as, this even component is given as x of t plus x of minus t by 2. And again we can see here, if I take x of minus t, it will be equal to xe of minus t, it will be equal to x of minus t plus x of t by 2, and which is equal to this xe of t. And now if you add these two components, then you will be getting x of t plus x of t by 2. That is, these minus t components will get cancelled, and whatever is remaining will be x of t plus x of t, that is equal to x of t. So therefore any signal x of t can be simply decomposed into two components, one is odd and other is even. So let us try to do that with this given example. So let us first try to find this x odd of t. So this is x of t minus x of minus t. So this is your x of t, and this is your minus of x of minus t, and we just have to add these two. So if we add these two, we will be having a signal from minus 2 to 2, but one will be below the t-axis and one will be above the t-axis. So basically we'll have something like this. So if we add x of t minus of x of minus t, we will be getting this part that corresponds to x of minus t, that is something like this, and the second part will correspond to x of minus t, which is something like this. So this will be minus 1 and this will be 1. But apart from that, we need to have a scaling of 1 by 2, that is we have to divide it by 2, and because of this amplitude will change to 1 by 2 and minus 1 by 2. So whatever we are getting here is basically the odd component, that is x odd of t. We can also observe here, that this signal is having an odd symmetry. That is, it is positive around t when t is greater than 0, and it is flipping its sign when it is t less than 0. So this is the odd component, that is x odd of t. Now let us look at how to get the even component, and that we get by adding x of t plus x of minus t. That is, we need to add these two signals, that is x of t and x of minus t. So we will be having from minus 2 to 2 an amplitude of 1, but now we will have to scale it by 2. That is, if we just have these two signals, we will get something like this. And its magnitude will be 1, but we are having a scaling of 1 by 2, so we'll divide it by 2, and therefore its amplitude will be 1 by 2. So this is the even component. This is my even component. And this is my odd component. So this is all about this question. Do you have any doubt? Anyone is having any doubt? Please unmute or put it in the chat box.
Madam, can you go back to the previous one, a second problem?
Yeah, sure. Yeah.
Here, is there any x of t is equal to minus x of minus t?
Yes.
Which implies x of minus t is equal to minus xt. Is it correct? Yeah. Oh, you look at the diagrams. Are they correct? The top two diagrams. X of minus t minus x of minus t. Looks similar, right?
Oh yeah, 1 minute, I'm sorry. 1 minute. I made a mistake in drawing this diagram. Yeah,
Yeah.
thank you for pointing it out. Yeah. Extremely sorry. Yeah. So this x of minus t is given by this diagram, I think this is fine
Yes.
because this is my x of t and this is my x of minus t. But when I'm drawing minus of x of minus t, then I need to draw minus of x of minus t. So basically we need to flip it about this t axis. So what this 2 component will become minus 2. That is, it will start from here and then it will go something like this. That is, at 2 will be having an amplitude of 2, which was earlier minus 2, and at minus 2 will be having an amplitude of minus 2, which was earlier 2 for x of minus t. And now if we compare x of t and minus of x of minus t, these both are same, and therefore we are having this condition that x of t is equal to minus of x of minus t, and x of minus t is equal to minus of x of t. Is it fine now?
Okay, madam. Thank you.
Yeah, okay, thank you, thank you. Anyone is having any doubt in this question?
Ma'am, can you once again explain the odd part?
For which question?
Third question.
Okay, for this question, you want me to explain how the odd part is getting created, like how we are trying finding it out, right?
Yes, ma'am.
Okay, 1 minute. I'll add one slide. Okay, so what is the definition of x odd of t? So it is x of t minus of x of minus t by 2. If you look here, what was your x of t? It was a pulse kind of thing from 0 to 2. So it looks something like this. So it is from 0 to 2 with amplitude 1. And if you look at, we need to find x of minus t. So whatever was present at 2, whatever was present at 2 will be now available at minus 2. So it will be like this. So this is your x of minus t. And then we need to find what is this minus of x of minus t. So that will come out to be something like this. So we are just flipping it about this t axis. So when its magnitude was 1 here at minus 2, now it will be minus 1. So it will be something like this. And this we can write as x of t plus minus of x of minus t by 2. So let us just focus on the numerator part, like just forget about this scaling by 1 by 2. So how can we obtain this part? So we can just obtain it by adding this signal and this signal. So if we do that, we need to add component by component, like for every value of t there will be an addition. So for if we look at this x of t signal, we can see that it is 0 from minus 2 to 0, so we don't have to care about that part, but it is non-zero from 0 to 2, so we need to check this range. Similarly, if we look here, it is 0 from 0 to 2, but it is having some value from 0 to minus 2. So the component that is contributing for x of t is this, and that will be given here and with magnitude 1. Now if we look at this part, that is minus of x of minus t, that also we need to add, that is we need to add this part also. So this part will contribute to a factor which is available from minus 2 to 0 with an amplitude of 1. So this is the numerator part. This is just the numerator. And in order to obtain the odd part, we need to scale it by 1 by 2. So at the end, what will we get? We'll get the same signal, but now it will be scaled by 1 by 2. So we will be getting a scaled version, something like this. But here it will be of magnitude 1 by 2, here it will be of magnitude 1 by 2, and it will be from -2 to 2. So this is the odd part. This is how we construct it. Is it okay?
Yes, ma'am. Thank you.
Okay, yeah, thank you. Any other question? Oh,
Madam, a general question.
yeah.
Any function, whether it is even, odd, or neither even nor odd, can be composed into even and odd, right?
Yes,
That's a
yes,
fact.
yes, yes. When you're decomposing your odd function, then like suppose that x of t is odd, then that is we already know that this x of t is an odd function.
Yes.
Then suppose we find x of t as x odd of t plus
Yes.
x even of t. This
Yes.
even component will not have any contribution, it will be 0. So
Zero.
whatever
Oh,
will be having will be at x odd of 0. So if you look at this and similarly if we are having an even signal, the odd component will not contribute to anything.
okay.
Yeah.
Okay, ma'am.
Okay.
Thank you.
You can take this as a small exercise like whatever we had in these first two questions. Like this first one was completely even signal and the second one was odd signal. So just try out and construct even and odd components of this signal. You'll observe that for an even signal, the odd component will go to 0, and for odd signal, the even component will go to 0. Just try it out once. It will be a good insight. Okay, let's move to next question. So this question is based on what is the unit impulse. So if you have seen the lectures, it will be clear that to define this unit impulse, an intermediate function was defined which was delta epsilon of t, which was defined as with an amplitude 1 by epsilon when t is ranging from minus epsilon by 2 to epsilon by 2, and it was 0 otherwise. So how did it look? It was something like this. It had an amplitude of 1 by epsilon, and this part was minus epsilon by 2, and this part was epsilon by 2. And the main property of this function or this signal was if we take its area from minus infinity to infinity delta epsilon of t dt, so that will be equal to minus epsilon by 2 to epsilon by 2, 1 by epsilon dt, and this results in 1. And after that, how did we define this unit impulse? So we took limit epsilon tending to infinity delta epsilon of t, and this we called as delta of t. So what we are doing, we are just shrinking this width and this amplitude is just shooting up. So that leads to your unit impulse, and we represent it with an arrow, something like this, and we write a 1 here, and this corresponds to its area. So let's get convinced that it has an area of 1. So we'll integrate with respect to t from minus infinity to infinity on both the sides. So we have minus infinity to infinity limit epsilon tend to infinity delta epsilon of t dt, which is equal to minus infinity to infinity delta t dt. and this part can be written as limit epsilon tends to infinity, integral minus infinity to infinity, delta epsilon of t dt, and we have seen that this value is equal to 1, and therefore area under this unit impulse is equal to 1. So this is the most important property of this unit impulse, that it shoots up very high near 0, and it has an area of 1, and its width is tending to 0, and its amplitude is very large, it is undefined. So this is your unit impulse, and this is one of the property of the unit impulse, one of the defining property of unit impulse, because this unit term comes because its area is 1. So let us try to solve some interesting questions by playing with the property of this unit impulse. Now we'll use two properties of unit impulse. The first one is delta of at will be equal to 1 upon mod a delta of t. This is absolute value. And delta of t minus t naught when scaled with f of t will lead to f of t naught and delta of t minus t naught. From where is this second property coming? So suppose I am having some signal f of t which is going something like this, and I have an impulse which is located at t naught. I am having it here, and we are having multiplication of this. So whatever signal is present here in these parts, it will be equal to 0, because your unit impulse is 0 here, and this impulse will get scaled by function value, that is value of f of t at t naught, that is f of t naught. So whatever it results will be equal to f of t naught into delta t minus t naught. So this is one of the important property of your unit impulse. So what are we given here? Let us look at this question. What is the value of this integral when the limits are given by this, that is this integral is varying, having its limits from a to b, and here we are having a equal to 3 and b equal to 6. So let us first try to understand and simplify this integral using these properties, and then we'll look at what role these limits play. So the integral is a to b e power minus t delta 5t minus 10 dt. So this can be written as a to b e power minus t delta 5 t minus t naught t minus 2 dt. Now we can use this first property and write this as 1 by 5 integral a to b e power minus t delta t minus 2 dt. Now using this second property, so this is from first property, and using this second property what we get is this e power minus t will take the value, that is this t will be replaced by this 2, that is it is simply like this, that is you are having e power minus t and you are having an impulse at t equal to 2. So what we'll get is an impulse at 2, but now it will be scaled by e power minus 2. Same concept. So we'll be having e power minus 2 by 5 integral a to b delta t minus 2 dt. Now what will be the value of this integral? Will it be 0? Will it be 1? Or what value should we just consider? Because here in the first question we found out that area under this impulse is equal to 1. But can we just put it as 1 in this question? Let us try to look at this integral graphically. So what we are having is, this is t, this is 0, and we are having an impulse at t equal to 2, which is something like this. Now suppose my integration limits are here. So if I am integrating over this region, my impulse is taking a value 0. So in that case, whatever integral function we are having, it will just simply go to 0. Similarly, if I am having that here, again it will go to 0 unless your impulse is included in the region of integration. You won't be getting the integration as 1. Therefore, the limits of integration are important to understand what the value we will be getting. So what are the limits that we are considering in this part? So these are a equal to 3 and b equal to 6. So these are somewhere here, a equal to 3 and somewhere here b equal to 6. Over this region we are integrating. So we can clearly see that if my impulse is located at t equal to 2 and I am trying to integrate that from 3 to 6, it's of no use. So irrespective of that impulse, the integral will be giving a value as 0 because this impulse is not located in this region. Similarly, if I am having this region, it is a equal to minus 3 and b equal to 1, my impulse is located at 2, that is somewhere here, and my region of integration is from minus 3 to 1. That is, I am trying to integrate in this region. Again, in this region, your impulse delta of t minus 2 takes the value of 0, and therefore again this integral minus 3 to 1 e power minus 2 by 5, which we have obtained here. I am repeating same thing here. Delta t minus 2 dt will be equal to 0. Now if we have this range, this second range, this third one. So what we are having, your impulse is at 2, this is 0, this is minus 3, and this is 3. And now I am integrating it in this region.
Now it will be 1.
Yes, correct. Now it will be 1. So this integral from minus 3 to 3 e power minus 2 by 5 delta t minus 2 dt, in this region this integration will lead to 1, and therefore the value will be e power minus 2 by 5. And this is a trivial case where my t is varying from minus infinity to infinity. So we can simply write it as integral from minus infinity to infinity. And since we are having entire t range,
So that will also be 1.
yes, that will also be 1. So when I am having from minus infinity to infinity, I have no issue of locating where my impulse is present because I am considering entire range. And for entire range, it is bound to give me an area under curve as 1 because it is the property of your unit impulse. So this will be and this will be equal to e power minus 2 by 5. So anyone have any question in these 4 parts that I solved just now? Please unmute yourself and go ahead and ask the questions. Okay. Then Another classification of signals that was covered in the class was based on periodicity. And upcoming questions, like next 2-3 questions we will be looking at, will be based on periodicity. So when do we say a signal is periodic? So if I'm having a continuous time signal x of t, and if I shift that signal by some factor, let's say t, capital T, and if these two are same for some t, like there exists some t for which this is okay, this equality is followed, then in that case we say that this is a periodic signal. Similarly, for discrete time signal, if I am having x of n is equal to x of n plus capital N, where this n is the period, means there exists some capital N such that after those many samples my signal starts repeating, that it takes the same value, then this will be again a periodic signal. This is for continuous time. And this is for discrete time. So this is how you define periodicity. Now what is the question? X of t is equal to cos 0.2 t. Is this signal periodic? And if yes, then find the fundamental period. So what is this fundamental period? It is smallest value of t for which this equation is satisfied. So that is known. Yeah.
Madam, can we say because it is a cost function, it
Yeah.
is has to be periodic?
It has to be periodic, but we'll try to formally prove it using this definition. You are correct that if it is a cosine function, then it has to be periodic.
Okay.
But we'll try to understand how, in general, we can go ahead and prove periodicity. Like if you are given any random signal, so you should be able to prove if it is periodic or not. Random means some function, not random and deterministic thing. If you are given any other expression for this signal, you should be able to understand that it is periodic or not using this definition, the basic definition. So let us look at it. If my x of t is equal to cos of 0.2 t, and now let us look at x of t plus t, that is equal to cos of 0.2 t plus t, that is equal to cos of 0.2 t plus 0.2 t. Now we know that cos of theta plus any integer of 2 pi will give me cos theta, will give me same value. Therefore, my this 0.2 t should lead to, this value should be equal to some integer multiple of 2 pi. Therefore, my t is equal to k2 pi by 0.2, that is k10 pi. So when I am finding this t, I am getting assured that there exists some t that guarantees me that this signal will repeat after some time. There exists some t, and therefore I can say that it is a periodic function or a periodic signal. But what will be its fundamental period? It will be t equal to 10 pi, because this is the smallest value that we can have. Else it will be 20 pi. Like if a signal is periodic with a period of 10 pi, it will also be periodic with a period of 20 pi. That is, if I'm having this sinusoid, something like this, this cos. So this is 10 pi and this is 20 pi. So after that also it will be continuing, and it will be periodic with period 20 pi also. But what fundamental period says that it is the smallest value for which it starts to repeat, and the smallest value will be t equal to 10 pi. Is this fine with everyone? So this t equal to 10 pi is the fundamental period. Okay. Now let us look at this question. Same question, but now it is discrete time signal. I'm asking this question to everyone that now is this x of n periodic? It is again a sinusoid. The only change is that it is a discrete time signal. What can you comment on its periodicity by just looking at this signal? Will it always be periodic, or there is something else that we need to look at? For discrete,
N should be integer.
what should be integer?
N value.
And why is it so?
Because in discrete time signals, the point values are not defined.
Exactly, correct. So this period n should be an integer value. Because this n is basically after how many number of samples it is getting repeated. Like if I'm having this function which is going something like this, so we can see that this is 0, 1, 2, 3. The third sample is the same as 0th sample. Similarly, the sixth sample is similar as 0th sample. Now this and this periodicity, it's with respect to some number of samples, and therefore it has to be an integer value. That's why this n should be an integer value, and then only we can say that it is a periodic signal. So let's try to understand if this is a periodic signal or not. So I am having this x of n is equal to cos of 0.2 n. This is equal to cos of 0.2 n plus capital N, that is equal to cos 0.2 n plus 0.2 n capital N. And we saw here that we need to look at this aspect, that is whatever is other than this theta, it should be integer multiple of 2 pi. That is this part here should be integer multiple of 2 pi. 0.2 n should be k times 2 pi, where this k belongs to integers, and therefore your n is equal to k times 2 pi by 0.2, that is k times 10 pi. Now if you look at this factor here, 10 pi, pi is an irrational number, and in n, for any value of k, you are never going to get n as an integer. And that's why this signal x of n, even being a sinusoid, it is an aperiodic signal. So this signal is not periodic. So for any discrete time sinusoid, if your period n is coming as some irrational number like this ratio 2 pi by this 0.2, if it is coming as some irrational number by any value of integer k, you are never going to get your signal or your n as some integer, and that's why in such cases you are never going to get it to be periodic signal. Now suppose instead of this cos 0.2n, if I am having cos of 0.2 pi n, then it will be, to check the periodicity, I'll take as cos of 0.2 pi n plus n, which will be equal to cos 0.2 pi n plus 0.2 pi capital N. And now if we look at this, 0.2 pi capital N should be equal to some integer multiple of 2 pi. So this pi gets cancelled and N is equal to 10. So in this situation, we are getting it to be periodic. So an important point that you can look here is, look at this factor here, 0.2n, and here it is 0.2 pi n.
Madam, the answer is n is 20 or n is 10?
N is 10. This pi is getting cancelled, not 2.
Oh,
Let me
not
write
2
it
pi.
clear. Yeah, let me write it more clear.
Okay. Sorry. I also mistake.
Yeah. So this is getting cancelled. This 2 is not getting cancelled. Yeah, so if you look at these factors, it is 0.2n and 0.2 pi n. There is a difference of pi factor in both of these. So if you look at the frequency here, like if you compare it with this factor, 2 pi f n, this f, this 2 pi f for the first case, let's say this is the first case and this is the second case. So 2 pi f for first case is equal to 0.2, that is your f is equal to 0.2 by 2 pi. So this is an irrational number because pi is irrational. And for the second case, 2 pi f is equal to 0.2 pi, and here my f is 0.2 by 2, which is a rational number. So if your f factor is coming as a rational number, you will be guaranteed to get a periodic signal. But if it becomes an irrational number, then in that case it would be an aperiodic signal when it is a sinusoid, that is if it is a cos or sine. Is it fine? Anyone has any doubt? Okay, let's go to the next question, and again we'll look at the periodicity. So here I am having two exponentials, that is first signal is x1 of t e power minus 2 pi t, and the second one is x2 of t, which is equal to e power minus j 2 pi t. So this is a real exponential, and this is a complex exponential. And we need to check if these are periodic or not. So let's look at the first signal, and let's say we look at x1 of t plus t. So it will be e power minus j 2 pi t plus t. Sorry. So this is equal to e power minus 2 pi t plus t, which is equal to e power minus 2 pi t into e power minus 2 pi t. Now this will be equal to x of t only when this factor will reduce to 1. So this factor will be equal to 1 if t is equal to 1. T is equal to 0. That is, basically we are not shifting the signal. So for fundamental period, your t has to be a non-zero value. and if it is zero, we are not at all shifting, like we are just looking at the x of t and trying to understand what is happening. But if for t not equal to 0, it won't be equal to 1, then in that case there exists no non-zero t such that x1 of t plus t is equal to x1 of t, and therefore this signal is not periodic. So your real exponentials not periodic.
So that, madam, that we can make a general statement, no?
Yes.
Any real exponential,
Yes.
basically, are not periodic.
Yes.
Yes.
Because your your exponential signal, if it is a decaying one, it will go something like this.
Yes, certainly not periodic.
Yes, so it won't be periodic. Similarly, if you are having non-decaying exponential, it will go something like this. So it won't be periodic in any circumstances. So if you're getting some weird observations by maths, you can just go and draw the diagrams, the graphs for it. Drawing graphs will give you more insights, and it becomes really helpful for solving questions in signals and systems. Now let us look at the second part, that is complex exponentials. So let us look at x2 of t plus t, and that comes out to be e power minus j 2 pi t plus capital T, that is equal to e power minus j 2 pi t into e power minus j 2 pi t. Now we want a value of t such that this will go to 1. And if we look at this factor here, it is cos of 2 pi t plus j times sine of 2 pi t, and we want this to be equal to 1, that is this factor should go to 1 and this factor should go to 0, and this will happen when this 2 pi t is some integer multiple of 2 pi.
Madam, that cos 2 pi t is minus j sin 2 pi t, no?
Sorry,
It is,
minus, yeah, sorry, minus j sin 2 pi t, and therefore t is equal to k times 1, that is k. So the smallest value will be equal to 1, and this will be our fundamental period. So we are able to find some value of t that will give me x2 of t plus t equal to x2 of t, and therefore this is a periodic signal. Is this okay? Anyone has any doubt? Okay. Now let us look at this question, that is xn equal to cos pi n square of 8. Now this is a sinusoid, but we can't just look at it and say if it is periodic or not, because it is a discrete time signal. We really need to get into the basic and look at it. So this x of n will be equal to this, and we need to look at the shifted version of it. So there is a question in chat. What can we say for discrete real exponentials? Okay, so if we look at discrete real exponentials, like let's say it is something a power j n, sorry, real exponentials, right? X of e power minus n. So how will it look? It will be taking some value at 0, it will be 1. Then at 1, it will be e power minus 1, then e power minus 2, and so on. Here it will be e, and so on. So again, for discrete exponentials, also real exponentials, it won't be showing periodicity. I hope it's clear. Like, how do you obtain this discrete exponential is just by sampling these. And therefore, it won't be periodic if I am having a discrete exponential. Okay, so let's get back to this question. So let us look at x of n plus capital N.
Madam, one general observation.
Yeah.
That if in the time domain, okay, so if continuous domain, if it is not periodic, there is no way in discrete it can be periodic, right? It is.
Yes.
So real exponentials, whether it is continuous or discrete, it uh, not periodic.
Yes, correct.
Okay, general statement.
Yes,
Yeah.
yes, it's a general state. Yeah. Thank you. Okay. So let us look at this x of n plus capital N. So this will be cos of pi by 8 n plus capital N square. So this comes out to be cos of pi by 8 plus pi by 8 n square. Sorry. One minute. Yeah. Pi by 8 into n square plus 2n n plus n square. So this is equal to cos of pi by 8 n square plus 2n n pi by 8 plus n square by 8 into pi. So now here we are having two cases. One is here, like we are having two factors that will affect the periodicity. This is the first factor. Let's say take the simple one first. This is the first factor and this is the second factor. Now we know that cos of theta plus k times 2 pi will give me cos of theta. And for this case, both first one and second one should lead to an integer multiple of 2 pi. So let's look at the first term. So that will be n square by 8 is equal to pi is equal to some integer multiple of 2 pi, and therefore your n square is equal to 16, which implies that your n is equal to 4. Yeah, this is the first one. And let us look at the second term. So that is 2n n pi by 8 is equal to some integer multiple of 2 pi. So this gets cancelled, which implies that your n is equal to k times 8 by n. So your maximum value for this n, for any value of n, will be equal to 8, and the minimum for k, we need to look at minimum. Sorry, for with respect to n, we need to look at the maximum. That is, it should follow for all the values of n. So we need to go for maximum with respect to n. And with k, we need to look at the smallest because we need to look at the fundamental thing. So this is the smallest value that will satisfy it. Now, both of these should be an integer multiple of that both of these factors should follow this equation simultaneously, and for that this period n naught should be equal to whichever is maximum of this 4 and 8, because if I consider n equal to 8, it is already an integer multiple of 4. Therefore this first term will be an integer multiple of 2 pi, but if I consider n equal to 4, the second term will not be an integer multiple of 2 pi, and therefore we need to consider the maximum value. That's why my fundamental period will be n naught equal to 8, and since we are able to find one such value of n, and hence it will be a periodic signal. Is this okay? Is this clear? Okay. Another classification that was considered in the lectures was based on energy and power. So first few examples will look at how to find the energy or power of the signal. So the first one is we need to find the energy of the power signal, like whatever electricity you are getting in at our home. So it is basically 50 hertz signal with an RMS value of 220 or 230 volts, and for that we need to find the energy. So what was the formula for energy? Energy was integral from minus infinity to infinity mod of x of t square dt. So this was the formula for energy. In this question, what is your x of t? Your x of t is 220 into root 2, since we have this as RMS value. Then sine 2 pi, its frequency is 50 t, and let's ignore the phase. Let's consider we are having a non-zero phase. So let's say we are having 220 root 2 sine of 100 pi t, and we need to find the energy of this signal. So let us use this formula, and let me denote this using E. So we have E is equal to integral from minus infinity to infinity mod of 220 root 2 sine 100 pi t mod square dt. So this is equal to 220 root 2 square, which is a constant, from minus infinity to infinity, sine square 100 pi t dt, which is equal to 220 root 2 square integral minus infinity to infinity 1 minus cos of 200 pi t by 2 dt. So if we look at this integral, what we have is 220 root 2 square by 2 t minus sine of 200 pi t by 200 pi from minus infinity to infinity. Forget this term here, just concentrate on this term. If I'm having this varying from infinity to infinity, this term will go to infinity irrespective of whatever we are having here. So this energy will tend to infinity. So for this question, for this sinusoid, my energy is tending to infinity. And when this energy is tending to infinity, it is definitely not an energy signal. So this is not an energy signal. What is an energy signal? An energy signal is a signal which is having a finite energy. That is, its energy is some finite value. It is not tending to infinity. And since here we are getting it to tending to infinity, it is not an energy signal. Now let us try to find the power of the same signal. And what was the value of power? So power was P equal to limit t tending to infinity 1 by t integral from minus t by 2 to t by 2 mod of x of t square dt. And now we need to find the power of this signal. So it will be limit t tending to infinity 1 by t integral minus t by 2 to t by 2 mod of 220 root 2 sine 100 pi t square dt. Now we have solved this integral till this value, this part. Till this part we are going to get the same thing, but only the limits will be changing. So I'm not solving this integral again. So what we will be getting is limit t tending to infinity 1 by t. Here we will be having t minus sine of 100 pi t by 100 pi from minus t by 2 to t by 2. So this can be written as limit t tending to infinity. This first thing.
1 minute, madam. Is it
Yeah.
sine 100 pi or 200 pi t?
Sorry, 200 pi. Yeah. So this first term will be leading to t, and this second term will be sine of 200 pi into t by 2 minus sine 200 pi into minus t by 2. So this is inside the bracket. Yeah. And if we take the limit t tending to infinity, this term will lead to 1, and as we are having t in the denominator here, this will tend to 0, and therefore my power is 1, which is less than infinity, which implies that this is a power signal. Is this okay?
Madam, just one again, a general question. Any signal can be either power or energy signal, right? But it can't be neither energy nor power, or both energy, both power. That can't be possible.
It can't be both power and energy signal, but there are cases when we are getting neither energy nor power. We'll look at those examples in upcoming question. I have added 1 or 2 questions like that where it is neither energy nor power, but yes, it can't be both energy and power, because you can see here, like if you see here, we are having a term 1 by t. If my energy is getting finite, we are getting a finite energy, this 1 by t will just make this power to be 0. So if it is an energy signal, its power will lead to 0. So that won't be the case.
Okay.
Yeah. Now let us look at classifying these signals as energy or power signal. Yeah. So the first question is x of t is equal to max of 0 comma t. So how will this function look like? So we are having this t, and it is 0 when t is negative, that is till 0 it is 0, and then it will increase with t with a slope of 1. So this is my x of t that I am having. So let us first find out its energy. So in that, E is equal to integral minus infinity to infinity mod of x of t square dt. Now if I am having mod x t, I am just having square of this value, and it is 0 from minus infinity to 0. In this region it is 0, therefore I can just focus on the limits from 0 to infinity. So this I can write as 0 to infinity. Your x of t is t, that means we'll be having t square dt. So here what I am getting is t cube by 3 from 0 to infinity, which tends to infinity. So my energy is tending to infinity. Now let us look at power. So what I am having, power is equal to limit t tending to infinity minus t by 2 to t by 2 mod x of t square dt. Again, from minus t by 2 to 0, this signal will be 0. So I can just focus on 0 to t by 2 limit. So that is equal to limit t tending to infinity, 0 to t by 2 t square dt, and this is equal to limit t tending to infinity, t cube by 3 from 0 to t by 2, and there is a factor of 1 by t here. So this will be equal to limit t tending to infinity 1 by t. This is t by 2 to the power 3 by 2. Now the power of t is 3 in numerator and it is 1 in denominator, and this t is tending to infinity, so therefore this power will also tend to infinity. Now in this example, both my energy and my power are tending to infinity. None of them are finite, and therefore such a signal is neither energy nor power. So this is neither an energy signal nor a power signal. Any doubt in this question?
Madam, only intuitively it doesn't make sense to me because the signal is increasing, so it has got infinite energy. So I feel it would be right to call it as energy signal rather than a power signal.
Its energy is not finite, sir. Its energy is also tending to infinity. And your definition for an energy
Oh
signal
yeah,
is it should be less than infinity.
energy power. Okay.
Yeah, both when your energy is less than infinity, it is an energy signal. When your power is less than infinity, it is a power signal. And here both your energy and power are tending to infinity.
Okay.
Yeah.
Yeah. Okay. Okay, madam. So,
Yeah. Okay. Let's look at the next part of this question. So here my x of t is this, and we need to classify it again as energy or power signal. So let us first draw this signal. First of all, it is multiplied by u of t, so it will be only available from 0 to infinity. And then it is also we are having a factor of e power minus t, which is getting multiplied by a sinusoid, and sinusoid can go up and down from -1 to 1, scaled by an exponential. So this signal will look something like this, and its magnitude will go to 0 at infinity. So this is your x of t, and we need to find its energy. Now we need to classify whether it's an energy signal or a power signal. So let us first look at its energy. Energy E is equal to minus infinity to infinity mod of x of t square dt, that is equal to, again your x of t is from 0 to infinity, so let us just focus on the positive t. So it is 0 to t sine square t into e power minus 2t dt. So this we can write as 0 to infinity 1 minus cos 2t cos 2t multiplied by e power minus 2t dt. Now this we can just split it as 0 to infinity e power minus 2t by 2 dt minus integral from 0 to infinity e power minus 2t cos 2t dt. Now if we look at this factor here, this is equal to 1 minus e power minus 2t. So let's go by step. E power minus 2t upon minus 4 from 0 to infinity minus this factor here will lead to an integral of e power minus 2t by 4 minus cos 2t plus sine 2t from 0 to infinity. This will lead to 1 by 4 minus 1 by 2 factor will remain here. When it is equal to infinity, this entire thing will be just made to 0 by this exponential part here, and when it is 0, we'll have minus 1 by 4, and this cos term will persist and the sign will go to 0. So we'll have minus 1 factor here. So basically we are having 1 by 4 minus 1 by 8, which is equal to 1 by 8, which is less than 0, less than infinity. Less than infinity, and therefore as my energy is finite, it is an energy signal.
Madam, without even computing integral, by looking at the graph, we can
Yes,
say that the diminishing signal, so energy is finite. We can conclude.
yes,
Yeah?
yes, but it is better to get sure many times
Okay.
by solving. I agree with you that if it is a diminishing signal, then it will have a finite energy. But suppose I am having a signal which is something like this, like it is getting diminished and then getting constant,
Okay, okay.
then you
Right.
can't say. Like till
Yes.
here you are getting an integral, like if it is just diminishing like this, then you will always have, it will tend to 0. But at infinity here, if it is a constant, it will have some value from this, let's say a point to infinity. It is a constant, some constant c from a to infinity, so this will tend to infinity.
Infinity. Okay, okay, I got it.
Yeah.
Thank you.
But like if you are having these standard signals like this exponential thing like e power minus t sine t, so these are very frequently occurring things if you are having some capacitive or inductive circuits. So in that case you can easily say that okay, if I'm having a sinusoid multiplied by e power minus t, and if it is multiplied by u of t, then I'm guaranteed that its energy will be finite. But yeah, if this u of t is not there, it will be extending from minus infinity to infinity. Then for all the negative value of t, your amplitude will shoot to infinity at minus infinity.
Okay, okay, okay.
That time you won't be able to say.
Okay.
Like
Right. But can we say in that case it is? We can't say that is a power signal, right?
for
If
power, no. If you consider energy to be finite, your power will be 0 because you are having this factor of 1 by t. Like if you look at the definitions here,
no, consider the signal x of t is equal to e power minus t without u of t.
we'll have to compute it. So, like
Okay,
I haven't computed it, but we'll
okay,
have to check if it is a power signal or not.
okay, okay. I think anyway it is coming. Proceed, madam. I understand.
Okay, yeah. Let us look at the next signal, and this is x of t equal to e power minus j t plus 4. So let us look at its energy. So its energy will be minus infinity to infinity mod of x of t square dt, minus infinity to infinity mod of e power minus j t plus 4 dt, and with a square. Now this is a complex exponential. This is a complex exponential which is cos of t plus 4 minus j times sine of t plus 4, and its absolute value, that is its magnitude, will be under root of cos square t plus 4 plus sine square t plus 4, and this will be equal to 1. So we are having it from minus infinity to infinity 1 dt. Again, this is a constant from minus infinity to infinity, and this will tend to infinity. Now let us look at power. We are guaranteed that as energy is tending to infinity is not at all an energy signal. So now let us see if it is a power signal. So let us look at power P as limit t tending to infinity, integral from minus t by 2 to t by 2, mod of e power minus j t plus 4 square dt. This is equal to limit with a factor of 1 by t tending to infinity 1 by t integral minus t by 2 to t by 2 1 dt, and this comes out to be limit t tending to infinity 1 by t into t, which is from minus t by 2 to t by 2, and this is equal to limit t tending to infinity 1 by t into t, which comes out to be 1, and this is less than infinity, and therefore this is a power signal. I hope this is clear. Now let us look at this question here, that is the fourth one, that is x of n is equal to e power minus 4n, and this is a discrete time signal, and for discrete time signal your energy is defined as summation n running from minus infinity to infinity mod x of n square, and your power is defined as 1 by 2n, sorry, limit n tending to infinity 1 by 2n plus 1 summation n running from minus n to n mod of x of n square. Now let us try to find its power first. So we are having p equal to limit n tend to infinity 1 by 2n plus 1 summation n is equal to minus n to n mod e power minus 4n square. So this x of n will be always positive, so no need of mod, so it will be minus 8n. Now I can split it into two summations, that is limit n tending to infinity 1 by 2n plus 1. It will be summation, first one will be from n equal to minus n to 1 e power minus 8n, and the second one will be limit n tending to infinity summation n is equal to 0 to n e power minus 8n, and it is multiplied by 1 by 2n plus 1. So let us look at this summation first. So this will, we can write it as, so this summation here we can write it as summation n is equal to minus 1, n is equal to 1 to n e power 8n. I'm just making a sign change, like some substitution as n equal to minus n. So my limits will be from n equal to 1 to n e power 8n. So this is a geometric progression and it is a finite one. So it will be e power 8n into e power 8, that is the first term, into e power 8n minus 1 upon e power 8 minus 1. Similarly, if we look at this summation here, this is also a geometric progression and this has the first value as 1. So this will lead to 1 minus e power minus 8. But now it is starting from 0 to n, that is there are n plus 1 terms. So it will be 8n plus 1 So it will be 1 minus e power minus 8 n plus 1 upon 1 minus e power minus 8. Now let us substitute it in the power equation. So this is equal to limit n tending to infinity 1 by 2n plus 1 e power 8 upon e power 8 minus 1 into e power 8n minus 1 plus summation limit n tend to infinity 1 by 2n plus 1 1 minus e power minus 8 n plus 1 upon 1 minus e power minus 8. Now if you look at this term here, this term, this, when my n is tending towards infinity, this will reduce to 0. Similarly, this term will also reduce to 0 as my n is tending to infinity. So this factor will become 0. But now if you look at this factor here, this factor, this is exponentially increasing with n. This factor here is exponentially increasing with n, and this is linearly increasing, and therefore this will dominate and this will tend to infinity. Therefore my power will be tending to infinity, which means that it is not a power signal. Now let us try to find its energy. So my energy is given as summation intending from minus infinity to infinity mod x of n square, which is equal to summation n running from minus infinity to infinity e power minus 8n. Now if we look at these factors here, these summations will come up, that is this one and this one, but now my n will be tending to infinity. That is, if I write it something like this, it will be n running from minus infinity to minus 1 e power minus 8n plus summation n running from 0 to infinity e power minus 8n. So if we consider this summation here, so this summation is a geometric progression, and now it is an infinite geometric progression. So we can just have it as 1 minus e power minus 8. So this is okay. Now if we look at this summation here, so this is summation n running from, we can just again make the same substitution, that is n as minus n, so it will become from n equal to 1 to infinity e power 8n. Now if we graphically look at this function, at n equal to 1 here it will be e power 8, then at 2 it will be e power 16. That is, it will tend to infinity, each of its term will tend to infinity, and therefore this entire summation will go to infinity, which means that again this energy will tend to infinity, and therefore it is not an energy signal. Is this okay?
Yes, madam. So generally, if the continuous counterparts of the signals or energy or power, same thing applies to discrete as well, right?
Yes, maximum times, yes. 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 Okay. Let us look at this last concept that was covered in the last lecture of week 1, and that is the classification of systems. And two classifications were given. One was based on memory, and other was based on causality. So for memory, it was said that if my output of the system depends on only the current value of the input, then that is, if I am observing the output at t equal to t naught, the output should depend only at on the input that was given at t equal to t naught, then such systems are known as memoryless systems. And for causal systems, it was said that if my output depends on the current time instant, that if my current output depends on current time instant or the previous time instants, then then it is a causal system. But if there is a dependency on future time instants, then it will be a non-causal system. So let's try to understand this using some examples. So let us look at the first one here. The first one here, the output y of t of a system whose transfer function is t x of t, that is, if I am having an input of x of t, the output that I am getting is t into x of t. So I'm observing output at t. So I'm observing output at t, and output of t depends, this is my input x of t, it depends only on input at t. There is no dependency whether it is t minus 1 or t plus 1. There is no such dependency. That is, if I'm observing my output, that is, if I'm observing y1, it will be equal to x of 1. If I'm observing y of 2, it will be 2 into x of 2. So this is the input at 2, at t equal to 2. And the output is depending only on the value of input that was at that given current instant, and therefore such a system is memoryless. Also, is there any future dependency, like output at t equal to 1 is not depending on output of t at t equal output at t equal to 1 is not depending on input at t equal to 2 or t equal to 3 and so on, and therefore there is no future dependency, which means that it is also a causal system. Since no future dependency, it is a causal system. Now let us look at the second one. This second one. So this second one is discrete time system, and y of n is output of the system t x of n, which is equal to, let us simplify this as this k is varying from x of n to infinity. So it is x of n plus x of n plus 1 plus x of n plus 2 and so on. Now again we can see that here the output is depending on current input as well as input at some other instances, which means
Non-causal. Yes.
that it is non-causal. Non-causality is coming because it is depending on future, like these are future values if I am having n as positive. So that's why it is coming as non-causal. So since there is a future dependency, that is, if I am having n as 1, if my n is equal to 1, then my y of 1 will be depending on x of 1, x of 2 and so on. These are future values. That's why it is non-causal. Also,
Madam, even if sigma k is equal to minus n to even if sigma k is equal to minus n to infinity, that also becomes non-causal, no?
Yes, yes.
Yeah. Okay.
And again, apart from this, as we said for the definition of memorylessness, that it should depend only on the current instant of input. Therefore, since we are having future dependency, that the current output is also depending on inputs at some other instances, this is also not a memoryless system. That is, this is a system with memory.
But the definition of memory is about past, right? Here, memory is about the future. Mm, maybe, yeah, maybe I don't know. I'm making.
Memory is something like you are storing something.
Okay, so here we are storing about the future. Okay,
Yeah.
right. Okay, so anyway, intuitively it's conflict with me. Yeah.
Okay. And let us look at the third one now. So third one is x of t is equal to x of minus t. It is x of t equal to x of minus t plus x, sorry, your y of t output is equal to x of minus t plus x of t. Now let us look at two cases. Like, let's see what is y of 1. It will be x of minus 1 plus x of 1. From this aspect itself, we are able to see past dependency. Now if I'm having a past dependency, then it is not a memoryless system. So it is a system with memory. Now, is it a causal system? Or
Yes, madam. Causal. Yes.
okay, okay. Now let us see y of minus 1. What is its value? X of 1 plus x of minus 1. This also looks fine. Now let us look at x of minus 2. X of 2 plus x of minus 2. This is a future value. And you have to look for all the possible values of t and all the possible values of n. If the future dependency is not there for all possible values of n, then only we can say that it is a causal system. But for negative values of t, we are getting future dependency, and therefore this is a non-causal system. Let us look at the fourth one. We have y of t, that is output, is equal to x of t plus x of t minus t naught. Now if I'm having y of 1, it will be where let's say this t naught is a positive value. T naught is greater than 0. So we are having x of 1 plus x of 1 minus t naught. This is giving me a past dependency, which clearly means that it is not memoryless. And if I look at x of minus 2, so it is x of minus 2, y of minus 2, it is x of minus 2 plus x of minus 2 minus t naught, and this value is again less than minus 2 as my t naught is greater than 0, which means that under any circumstances for all the values of t there will be only dependency on past values, and therefore this system is causal. It is not memoryless, but it is causal. So these were the two basic classifications of systems that were covered in the first week. So for this week, these are the questions that I had planned to cover. And if anyone has any doubts in any questions, please let me know. If there are no questions, that was all that I wanted to cover today. If you want if you want to give any feedback, or if you want me to cover some things in more detail or in some different fashion, please let me know. I'll do that from next week. Okay, so I have a request here that can I repeat second question. So let us look at the second question. Second question. Which one? I understood, Anita, that you want me to cover second question, but entirely second question. Okay, second question, part 2 and part 3. Okay, I'll repeat it. So, if we consider second question, if we look at the second question here, so we are using two properties of unit impulse. The first one is this, that is delta at is equal to 1 by mod a delta t, and second property is f of t into delta t minus t naught is equal to f of t naught into delta t minus t naught. So for second and third part you are asking me, so let us look at this again properly. Yeah, so this integral value which we had found out was integral a to b, and it was coming out to be e power minus 2 by 5 delta t minus 2 dt. And if we look at this impulse here, it is 0 here and it is 2 here. The impulse is located at this part. So this is my delta t minus 2. Now when my a is minus 3, that is my a is somewhere here, and my b is 1, so my b is here. So in what region am I integrating? I am just looking at this region here. So in this region, are we having this unit impulse present? No. This unit impulse is 0 when my t is not equal to 2. For all other values of t, my unit impulse is taking the value 0. So this is equal to 0 for this given range. For given range. That is, for this range, it is equal to 0, and that's why this integral goes to 0. Similarly, now if we look at this case here, that is a equal to minus 3 to 3. So my unit impulse is present here, that is delta t minus 2. It is present at t equal to 2, and my a is minus 3. So this is my a, and this is my b, that is 3. And this green shaded part is the area where I'm integrating. But now it is having this unit impulse present. So when this unit impulse is present here, if you look at this part, this, if this part is present between the region, then its area will always be equal to 1, and therefore integration over this minus 3 to 3 will lead to this value. That is, if I write it as e power minus 2 by 5 integral minus 3 to 3 delta t minus 2 dt, this integral will be equal to 1, and that's why I am getting this value as the integral. Okay, so I am getting another question that if t naught is greater than 0, then why t depends only on current inputs. Wait a minute. So you are asking for this question, and you are saying that if my t naught is greater than 0, that is this factor is greater than 0, I am taking it to be greater than 0, then you are saying that my y of t depends only on current inputs. No. See, look at this. My y of t is equal to x of t plus x of t minus t naught. Now let's say my t naught is equal to 2. Let's say, and if I am finding y of 1, then it will be equal to x of 1 plus x of 1 minus 2, and this is equal to x of minus 1. So it is depending on the input at 1 as well as input at t equal to minus 1. Therefore there will be a path dependency for all values of t when my t naught is greater than 0. Okay, I hope it is clear. And another request I am getting is for question 1, that is this odd and even signals classification. Okay, so I'll explain the first one. Do I need to explain entirely? Okay, let's start it. X of t is equal to u of t plus 2. Let's do this completely again, the first one. Yeah. So this x of t was given as u of t plus 2 minus u of t minus 2. So let us first look at what is this u of t. So this u of t is my unit step function. It is equal to 1 when my t is greater than or equal to 0, and it is equal to 0 when my t is less than 0. So it looks something like this. It is 0 here. Let me use different color. So it is 0 here, and then from t equal to 0 it takes the value as 1. So this is my u of t. And the signal that I have been given is x of t equal to u of t plus 2 and u minus u of t minus 2. So let us understand these signals individually, one by one. Let's look at them one by one. So let us look at this u of t plus 2 first. So I am looking at u of t plus 2. Now we know that u of t, this u of t is equal to 1 from t equal to 0. So this u of t will be 0 from the case when my t plus 2 is equal to 0, or for all the value of t that satisfies t plus 2 greater than or equal to 0, it will be taking a value of 0, a value of 1 from this definition, which means that if my t is greater than or equal to minus 2, then it will be a non-zero, that is from minus 2 it will take a value of 1 and will extend this to infinity. So this is my u of t plus 2. another thing is, next signal that we have is u of t minus 2. So now for this, my t minus 2 greater than or equal to 0, which means t greater than or equal to 2. For this value of t, my signal will have a non-zero value, and then it will be having a 0 value for all the values outside it. So it is something like this. From 2 it will be 1, and before that it will be 0. Now how to construct your x of t? Your x of t is simply subtraction of these two signals. So from minus 2 to 2. So let us look at you have to do point by point subtraction. So till minus 2 both of these signals are 0. So it's okay. Both of these signals are 0 in this region. Now from minus 2 to 2 we observe that this u of t plus 2 is 1, whereas u of t minus 2 is 0. So from this region, that is minus 2 to 2, you will be having a signal with magnitude 1. Now from, if you look at this 2, your 2 is here, from 2 to infinity we can observe that both of these signals are having same value of 1, which will cancel each other, and again we'll be having 0. So this is your x of t. And now we need to find whether this x of t that we have obtained is an even signal or odd signal. And what is the definition for even signal? It says that if my flipped version, that is x of minus t, if it is equal to x of t, then it is an even signal. So let us look at how your x of minus t looks. So let us look at x of minus t. When you need to flip it, like when you need to find x of minus t, you need to just flip it about this vertical axis. Like you need to flip it about this, like you need to find a mirror image with respect to this axis, and that's why whatever was present at 2 will now be available at minus 2. Like if you look here, your x of t is defined like this. So if whatever signal was present at t equal to 2 will now be present at t equal to minus 2, and accordingly we can draw this signal as this. Whatever was present here at t equal to 2 will be here at t equal to minus 2, then from minus 2 to 2 it will be a straight line, and whatever was there at t equal to minus 2 will be present here. So this is the signal. Now if you observe these two signals, these two are exactly same, which means that if my x of t is equal to x of minus t, then this signal is an even signal. Now in second question, what we had was, in second question, our x of t was defined like this. X of t is equal to t into u of t plus 2 minus u of t minus 2. This part, that is u of t plus 2 minus u of minus t plus 2, we had seen in this question, the first one. This. So this was the first part here. Now the second part was t, and t, if my this signal, let's say this is some x hat of t, so my x hat of t is equal to t, means it is a straight line from minus infinity to infinity with slope 1, which will look something like this, and this is getting multiplied. This signal, these two signals are getting multiplied, and therefore the resultant signal will be only this part, on this x hat of t, but only in this region, because outside these regions, this region, your u of t plus 2 minus u of t minus 2 is 0, and that's why whatever you are getting x of t is this. and it is 0 after this. So it is 0 here. So it is something like this. And now we need to check if it is an odd signal or an even signal. So for that, first we find out x of minus t. We need to find out x of minus t. So again we need to flip it about this axis. So whatever was present at t equal to 2 will now be available at t equal to minus 2. So whatever was there at t equal to 2 is now available at t equal to minus 2. Similarly, whatever was there at t equal to minus 2 is now at t equal to 2. And similarly, every point by point you have to do it, and you are just flipping it about with respect to this axis, about this axis. And if we observe x of t and x of minus t, those two are not equal, which clearly means that it is not an even signal. So if x of t is not equal to x of minus t, this implies that it is not an even signal. Now let us try to see what happens if I flip it about t, that is minus of x of minus t. In that case, this minus 2 will just go up, like it will be flipped about this t axis, mirror image about this t axis, and therefore if my magnitude at t equal to 2 was minus 2, it will become 2. Similarly, if it was t equal to 2 at minus 2, uh, if it was 2 at t equal to minus 2, it will just become minus 2 at t equal to minus 2. So if we compare now x of t and x minus of x of t, we can see that both of them are equal. That is, this equation is getting satisfied. X of t is equal to minus of x of minus t, which implies that x of minus t is equal to minus of x of t, which means that it is an odd signal. But in the third example which we saw, we found that it was neither an odd nor an even signal. So here your signal was x of t is equal to x of t is equal to u of t. So this is u of t minus u of t minus 2. And if I subtract these two signals point by point, this is the x of t that I obtain. So after obtaining that, I need to check if it is even or odd, and for that I'll just see x of minus t and minus of x of minus t. So first I'll find out x of minus t. So if I look at x of minus t, it is simply a flipped version of this about this vertical axis. That is, it's a mirror image of this about this x of t axis, and that we obtain something like this, that whatever was at 2 will be now available at minus 2. Now we can clearly see that these two are different signals. X of t is not equal to x of minus t, which means that it is not an even signal. Now let's check the possibility of odd signal. So for that, we can check what is minus of x of minus t. That is, we need to flip it vertically about this t axis. That is, if its magnitude was 1 here, it will become minus 1. So this is my minus of x of minus t. Again, this x of t, this x of t and minus of x of minus t are not same, which means that it is not an odd signal also. It is neither an odd signal nor an even signal. But then I said that for any given signal, we can decompose it in two components. One is odd component and other is even component. And the odd component is given by this formula x naught of t is equal to x of t minus x of minus t by 2, and x even of t is equal to x of t plus x of minus t by 2. And using these two formula, we can construct the odd component and the even components for any given signal. So this was question 1. Do you have further doubt in this? Okay. Any more doubts? If there are no doubts, that was all from my side in this session. Thank you so much. Hope to see you again on next Sunday. Thank you. If you have no further doubts, you may leave the meeting. Thank you again.
Thank you, madam.